Hmm. Alrighty, let's see if we can make this link available. Do 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 do. Really should get some waiting room music for while I set this up. Hmm. Huh, weird. So it appears to be working, but YouTube tells me it's not working. So YouTube is a liar. Oh boy, that delay is painful. It's like 30 seconds. Let's see, let's see. All right, well, we've got one person here. Hi, Jake. Um, I'm not sure how many other people are going to show, and our numbers are pretty low in general. And you guys are the only ones really prepping for an exam, so this might end up being more of a one-on-one or very small group exam review session. I just copied in a question that Michael had sent to me by email a few days ago, but I hadn't had a chance to respond. I was going to answer that one first. Jake, if you have any requests for questions that you would like to see done or a type of question, then we can work on that. What was it that Michael was asking me about this one? He said, so this is from May 2016, Time Zone 1, Paper 2. It says, find the angle between AB and OC. Would that be on the left side or right side of OC? Seems kind of confusing because either angle seems like it could be found. I think I could figure out how to get the angle. Do you know which one it might be talking about? So based on the way that the question is worded here, I would assume that this is actually looking for, if you continue OC this way, it's looking for that angle. So you are looking for the acute angle there. So this is a dot product question then. Vector AB we would have found earlier. Let me see. So that's A, that's B. So it would be 6 minus -3, 4 minus -2, -1 minus 2. So that works out to be, what, 9, 6, -3. So that's the vector AB. They provide you with the knowledge that vector OC is 3, 2, 0. And if I'm looking for an angle, my mind should go to thinking about dot products of two vectors. Because if I know the dot product of two vectors based on their components, I'm able to relate that to the magnitudes and the angle. So I think, how is that given in your formula booklet? Do they write it like this? Cos theta is equal to the dot product over the product of the magnitudes? I think that's how it's given. So you would need to find the magnitude of AB, the magnitude of OC, and the dot product of them. If I dot them together, I'll have cos theta is equal to 9 times 3 plus 6 times 2 plus -3 times 0, so I'll just leave that part out. And then I'll have to divide by their magnitudes. So let's see, magnitude of AB is going to be the square root of 81 plus 36 plus 9. So square root of 126. And the magnitude of OC, square root of 9 plus 4, or root 13. So root 126 times root 13, go under here. I guess I should have figured out my numerator as well. 9 times 3 is 27 plus 12. So 39 over those radicals. And now I got to get out my calculator for this. 39 divided by square root of 126 times square root of 13. And then I'm going to do cos inverse of that value. Although my calculator right now is in radians. Okay, cos inverse of the previous answer. And so I get that theta is equal to 15.5 degrees. Which makes sense if it's an acute angle, or it appears to be acute, at least based on the diagram. All right, so that's Michael's question answered. I'm going to go back to the chat here and see if Jake has queued up any requests, which he has not yet. So, all right. While Jake is queuing up any requests, I'm going to just reach out to Michael and say I think it's the acute angle that we're talking about here. In fact, I have the mark scheme, so I could even jump in and check that out, couldn't I? What was it? May 2016, time zone 1, paper 2, he said. Time zone 1, paper 2. I'll get that actually off the screen so that it doesn't pop up unnecessarily in the stream. Oh, that's not the mark scheme. Okay. This was question 10, I think. Yep, last one. Let's see. Yep, 15.5 degrees, that's what it is. Uh, Ooh, okay. Well, there's a healthy list of questions. Thank you, Jake. All right, let me pull open the textbook. It seems like you've been doing a lot of the review from those miscellaneous questions, which is good. I mean, those questions are pretty challenging. I hope you have done some past paperwork as well. Um, so I'm just going to quickly screenshot your requests. Oh, my screenshot function is not working consistently lately. Let's try this again. There we go. All right. So Jake's list of requests here, textbook pages, or textbook section 25A, 548D. All right, that's somewhere towards the end, so I'm going to guess page 650 or something like that. Oh, very close. All right, question 5, binomial expansions question. Looks fun. I'm just going to pop these ones in. Why are they coming in so small? That doesn't make any sense. 48D. Probability question. Very good. 62. Oh, yeah, 62 is a question. Okay, so I knew you had asked about 62 because I guess you chatted with Miss Doldhart about it and tried to work through it. She asked me about that after you had visited her. So that one I'm already familiar with. She and I had a talk about the best way to solve that. 73b, another probability one. Come on. Screenshot tools, so bad. I swear, Windows updates sometimes break as many things as they fix. And, oh, 74 and 86b. I probably could have got 74 in the same pass, but oh well. 74 and 86b. Ooh, another binomial expansion one. The screenshot messed up again, but I'm not going to do that a second time. I'll just paste it in as is. Okay. Got a whole bunch of questions laid out and ready to go on some somewhat varied topics. Okay, let's go back up to this first one. So for number 5, you got part A but couldn't figure out part B. Right. Okay. So we looked at some questions like this during the year where it's a binomial expansion problem and then there's a part that comes after where you have to multiply in another binomial into the mix. And so at this point, you've already got it expanded, right? So you have, what would it be? X cubed. Actually, here, I'm just going to do part A because I need to work out the expanded form. And I don't want to goof on that and then mess up the rest of the question. So plus 3 times x squared minus 2 to the 1 plus 3 times x times minus 2 squared plus 1 times minus, oh, getting ahead of myself, minus 2 cubed. So when I simplify this, I get x cubed minus 6x squared. So that's 4 plus 12x, and then minus 8. So it ends up with this alternating plus minus thing going on just because that negative 2 term, if it has an even exponent on it, then it ends up being a positive term. If there's an odd exponent on the negative 2, it ends up being a negative term. So you have that from part A. But then what they're saying is if you were to do this, 3x squared minus 7 times that cubic we just got, the question is basically what's the x cubed term going to work out to be? So somewhere when you expand this out, you're going to end up with something that has an x cubed on it, and so what does that term look like? So in this situation, if you look at what actually happens as you multiply it out, when I do 3x squared minus 7 times x cubed minus 6x squared plus 12x minus 8, when I'm multiplying that out, I am multiplying this 3x squared to every single term from my binomial expansion. So it's multiplying all the way along. I'm also multiplying that minus 7 to each of those terms all the way along. And so we have to ask ourselves, rather than multiplying the whole thing out, what's the most efficient way to figure out which terms will end up with x cubes in the result? So the easiest one perhaps to look at is actually the minus 7 situation. So when I go ahead and I multiply that minus 7 into the set of brackets, the only way that minus 7 multiplied with something else is going to be an x cubed term is if I am taking minus 7 times that x cubed term in the second set of brackets. That's the only way I'm going to get an x cubed term there. So doing that minus 7 times x cubed will give me minus 7x cubed. The 3x squared, on the other hand, I don't get an x cubed term by multiplying it with the x cubed. That would actually give me an x to the 5 term. Uh, the term I would need to multiply it with would be just a term that has a single x, because then the x squared times the x will give me an x cubed. So if I multiply that 3x squared to that 12x, that's going to give me my x cubed term there. And combined, when I simplify and gather like terms at the end, that's going to give me my overall x cubed term. So 3x squared times 12x is 36x cubed. But then I'm subtracting 7x cubed because that's my other x cubed term. And so this simplifies to be 29x cubed. And that's the term that I'm looking for right there. So without expanding everything else, you can kind of logic your way through it and say, which term will I multiply the minus 7 with, or the 3x squared with, to get the type of variable that I'm looking for? So in order to get an x cubed, I had to multiply the minus 7, which is just a constant, with an x cubed. That's the only way I was going to get an x cubed from multiplying the negative 7 through. And to get an x cubed from multiplying the 3x squared through, I had to just multiply it with a linear term, a single x, to bump that exponent up to an x cubed. And so that's how you would do that one. I mean, technically this one, you probably could expand the whole thing out, and it wouldn't be a huge deal breaker. A little bit of time lost, but no real harm or foul there. You could get to the answer anyway. But this would be the more efficient way, is saying, how do those terms pair up to give me the type of term I'm looking for? So that's the key to that question. So we'll move on to number 48. Hopefully that was able to clarify some things there for you, Jake. And if not, let me know and I can revisit it. Important thing to remember is the stream's out of sync by about 30 seconds, I think. I think that's the delay. So if you do have a concern, just let me know in the text chat as quickly as possible, and then I will get to it. Anyway, on to number 48. And you said 48D, so that means you made it most of the way through this question. Now, me looking at it from scratch, I'm going to go through just to get my bearings. So we have bag C contains 4 blue and 1 yellow tickets. Bag D contains 2 blue and 3 yellow tickets. An ordinary 6-sided die is used to select one of the 2 bags. If a 1 or 2 is rolled, bag C is chosen. Otherwise, bag D is chosen. A ticket is drawn at random from that bag. Okay. So, dependent probabilities. So I'm going to just fill in the tree. So I'm rolling a 6-sided die. If you roll a 1 or 2, that's the only way you're going to pick bag C. So there's a 2 in 6 chance you go down that route, which it's probably easier to simplify to 1 in 3. And then to pick bag D is just the complementary probability. So 4 over 6 or 2 over 3. So I filled in that part of the tree. In bag C, there are 4 blue and 1 yellow. So the probability of blue is 4 in 5. Probability of yellow is 1 in 5. For bag D, probability of blue is 2 out of 5, and yellow is 3 out of 5. Just as a point of interest for this question, I always get some students who see this kind of question and think, oh, there'll never be something where they give you the tree diagram and have you fill it in on an IB exam. Those questions actually aren't as uncommon as you might think. They do show up a fair bit. I'm sure if you've been going through past papers, you've likely stumbled across one of them by now. So yeah, there are sometimes tree diagram questions where they give you the tree and have you fill it in. There will be other times tree diagram questions where maybe you have to create the tree. It kind of depends on what they're looking to assess in the question. So part B asked us to find the probability that a yellow ticket is drawn from bag D. So that would be us looking for the probability of pulling from bag D and getting a yellow ticket. So I just have to multiply down that branch of the tree, which corresponds to this one. That's bag D and yellow ticket. So it would be 2 over 3 times 3 over 5 which is 2 over 5. That one's pretty straightforward. Find the probability of drawing a yellow ticket from either bag. Okay, so now we're looking at more drawing a yellow ticket here and here together. Now those are mutually exclusive events, right? You can't pull a yellow ticket from bag C and from bag D if you're only pulling one ticket. It's a one or the other thing. So the probability of just getting a yellow ticket would be the probability of getting it from bag C plus the probability of getting it from bag D. So from bag C, it'll be 1/3 times 1/5. And from bag D, we already figured it out. Oh, I said, no, 2 over 5 was right. Sorry. For a second there, I was second guessing myself because the denominators didn't match, but I forgot I reduced the 3's. So it would be plus 2 over 5. So now I'm going to need to get a common denominator again anyway, so maybe I shouldn't have reduced. Live and learn. This is, I think, one of the reasons why the IB is not a stickler about you reducing fractions, because a lot of times you'll reduce it and then have to scale it back up. Anyway, so there we go. 1/3 times a fifth is 1/15th, and then 2 over 5, if I hadn't reduced that, it would have been 6 over 15. So I combine those together, and I get 7 over 15 as the chance of getting a yellow ticket. Part D, which is the part, Jake, that you're actually asking about, and so I'm sorry for us taking such a meandering tour to get here. If a blue ticket is chosen, find the probability that it came from bag D. So what we're looking for here is the probability that the ticket's from bag D given that it's blue. Now, you have to do a little bit more work to get this because that's not this probability, which I think would be the most common mistake made in this question. This is actually the probability of a... Oh, sorry, I'm pointing to the wrong spot in the tree. Most people would guess it was this probability, but this is actually the probability of it being blue given that you were from bag D. The probability that you're in bag D given that the ticket was blue is a slightly different thing. So... Okay. Kyung is laughing at my word choice. Thanks, Kyung. So anyway, the probability of D given B is probability of D and B. So the probability that it is blue from bag D divided by just the overall probability that it's blue. This question is... I don't know. It's a little bizarre. I don't feel like the IB would have actually structured it this way on an exam. I think this is the Hayes textbook people kind of making something up that doesn't really fit well. Normally, if they asked a question like this, it would likely be built off of the work you had done previously. So I'm actually kind of surprised that this isn't if a yellow ticket is chosen, find the probability that came from bag D, but whatever. We'll figure out this separately, the probability of B. We'll use the same strategy that we did for probability of Y, or probability that it was yellow. So this probability of B will just be the probability that it's blue from bag C plus the probability that it's blue from bag D. So that works out to be 1/3 times 4 over 5 plus 2 over 3 times 2 over 5. And I'm double checking that because I've now twice made errors reading from the tree. So I'm beginning to second guess my ability to read off of this page, which is not good. I think that works out. 1/3 times 4 over 5. Yep. 2/3, 2 over 5. Yep. So I get 8 over 15. That will be my denominator here. And the probability that goes in the numerator is actually just this one, because that's the probability of getting a blue from bag D. So I'll just pop 4 out of 15 there on the top. The over 15s I can just reduce out really quickly. Just multiply out 15, or multiply on top and bottom by 15, and I get 4 over 8, which is just a half. So there you go. If a blue ticket is chosen, there's a 50-50 chance it came from one bag or the other. Now, Jake, you didn't request E, so I'm assuming that you're okay with that. It is an expected value question. Actually, maybe let me type in the chat just so I can get a quicker response. Oh, okay. So Jake was good with E, so we're going to move on. For everybody else, it's expected value, so you know you get $6 for a blue and 9 for a yellow. So you just have to multiply those with the probabilities of those specific outcomes and add it up, and that's how you'll get your expected value. If that turns out to be an issue for anybody else, I'm happy to go back to it. All right, this next one. So this is the one that I was saying earlier. I was talking to Ms. Doldhart about this one because I guess it came up a few times in Extra Help, and we've done a question like this before too, because it's in the review set for the sequences in series chapter. The tricky thing is the one from the review set, there were actually two ways that you could do it. You could just plug in numbers. You could plug in 1, and you would get S1, which is actually just the first term. And then you could plug in 2, which you would know is U2 plus U1, and you'd be able to do some subtraction to get the second term, and so on. The issue here, apparently, and I haven't tested this myself, but this is what Ms. Doldhart said came up as an issue, is that when you try to do that, to look at this pattern, it's actually not arithmetic or geometric, it's quadratic, I guess. And so that strategy doesn't work. And I think that is what causes this problem to be really challenging, because we've previously talked about how, oh, there's two ways you could do this, and this particular scenario actually doesn't work with the one way, or at least not very smoothly. So the big kind of piece of insight that you need to have here is just that if you were to take the sum of the first n terms and subtract the sum of the first n minus 1 terms, you will just get the nth term, right? The idea is that s n minus 1, the sum of the first n minus 1 terms, is u1 plus u2 plus all the way along until we get to the n minus 2 term plus the n minus 1 term, and then that's it. Whereas the sum of the first n terms is basically that entire list again, but at the end we've just added in the nth term. So by finding the difference, subtracting one from the other, we're just going to be left with that nth term. So the way to get the n minus 1th term would be to just sub n minus 1 into this equation up here. So instead of having n cubed, I'll have n minus 1 cubed. Instead of having plus 2n, I'll have plus 2 times n minus 1, and then I'll just subtract 1 at the end. So we've got a little bit of expanding to do here. This is a binomial expansion. It's not too tough because it's just a minus 1 there. So it's going to have our coefficients, as we normally have them, the 1, 3, 3, 1. But it's just going to alternate for whether it's positive or negative, which is nice and easy. The second part, 2n minus 2 minus 1, and then I've just got to tidy this up. Or at least it's in my best interest to tidy it up because I'm about to go and subtract it from something else, and I might as well do my gathering of like terms now. 3n plus 2n is 5n, and if I gather the constants at the end, minus 2, minus 1, I end up with a minus 4. Okay, so now to take that back over to here, And I don't like that I wrote the UN on the right side. Let me write that on the left. So I'm going to do n cubed plus 2n minus 1, and then I'm going to subtract that other one that I just got. N cubed minus 3n squared plus 5n and minus 4. All right, so that negative is going to go straight through the brackets, and it's going to flip the sign on everything. So minus n cubed plus 3n squared minus 5n and plus 4. And if I tidy that up, the n cubes are going to go. I don't think anything else is just toast from this. I have 3n squared left. 2n minus 5n is minus 3n. Minus 1 plus 4 is plus 3. So there we go. So the general term is 3n squared minus 3n plus 3. So that's not arithmetic or geometric. So had you tried to do it any other way, you wouldn't have been able to articulate the pattern as clearly. I mean, if you remember grade 10 really well, where I'm fairly confident you would have done table of values with quadratic data and then done finite differences, you could have very well set up a table of values and figured that out. I don't know. It probably wouldn't have been as easy. It certainly would have been more time consuming. All right. I'll move on to the next one, which is another probability question. For the other people who are now here, so I believe Jake and Young are still here. I'm not sure who else, based on the number of people watching. If you have any questions, please do put them in the chat. So Jake came and requested a whole bunch from the miscellaneous questions in chapter 25. And I started off by doing a past paper question that Michael had sent me by email. So if anybody else has any requests, I'm basically just, I want to answer the questions you're most concerned about. Even if you don't have a specific question, but maybe there was a topic that you want to see a problem on, we can do that too. I can just go dig through my exam bank and find something that would be appropriate. So, on to number 73. Hat 1 contains 3 green and 4 blue tickets. Hat 2 contains 4 green and 3 blue tickets. One ticket is randomly selected from each hat. Find the probability that the tickets are the same color. So here's a tree diagram question where we have to make the tree ourselves. So we'll say, I'm assuming there's an even chance of, one ticket is randomly selected from each hat. Gotcha. Okay, so we pick from hat 1 first, and we either get green or blue. So this is hat 1. And then we pick from hat 2, where we can again get green or blue. And so, probability of green in the first hat is 3 out of 7. And for blue, it's 4 out of 7. Probability of green in the second hat is 4 out of 7. And probability for blue is 3 out of 7. Okay, find the probability that the tickets are the same color. So that would correspond to this branch or this branch. So the probability that they are the same will be 3 over 7 times 4 over 7 plus 4 over 7 times 3 over 7. So it's 12 over 49 plus 12 over 49, or 24 over 49. That's it for that one. Given that the tickets are different colors, what is the probability that the green ticket came from hat 2? Oh, that's interesting. Okay, so given that the tickets are different colors, what's the probability that the green ticket came from hat 2? So we're looking at basically that the second one, oh, this is worded so so oddly that I'm actually wondering if it's easier than I'm thinking it is. But I'm basically being told that I know that they're different, and I want to figure out that it was a green from hat 2, not from hat 1. So basically, this is the only way that they are different, also coming from hat 2. So I want to see here. This is what it would look like when I go to do my dependent probability. And so I think that the probabilities are actually pretty straightforward to find here. The probability that they're different. Sorry, I think I'm just intrigued by how cheeky this question feels because it seems like it's a lot of work and it's not actually. So the probability that they're different, that's just the complementary probability to that they're the same. So we figured out that the probability of them being the same is 24 out of 49. So the probability that they're different is just 25 out of 49. In terms of what goes in my numerator, the probability that it's a green ticket from hat 2 and they're different, well, the only branch that that corresponds to is this one. That's the only place where they can both be different from each other, and the second one, and the hat 2 draw is the green one. So I really just have to multiply down that branch, which gives me 16 over 49. So in my numerator here for this probability, I end up with 16 out of 49. In my denominator, I end up with 25 out of 49. And so that gets me 16 out of 25, which I was thinking would reduce, but it actually doesn't. They're both perfect squares, but that's not helpful. So that would be the probability that if they were different, the green ticket came from hat 2. So anytime you're given one like that, where it's saying, given that this is true, what's the probability of something else? It's really helpful sometimes to actually set up your notation properly for dependent probabilities. The formula that you are given in your formula booklet says to you very clearly that if you're looking for the probability of B given A, it's just the probability that both of those things happen divided by the probability that A happens. And so to that end, if you set that up, sometimes it helps to actually really frame the way you're thinking through the question. So initially, because of the wording of it, it was saying that they're different colors. What's the probability that the green ticket came from hat 2? I thought, oh, geez, it seems like there's a lot of things to consider. But then as soon as I wrote it out with notation, I realized, oh, no, wait, those probabilities are a little bit more direct to find. And so, I mean, as long as you set the question up properly, you should be in pretty good shape to actually solve it. So I don't know if there are any questions about that one. I'm not seeing any new requests yet in the text chat, so I hope we're okay. And we'll move on to the second last of the questions that Jake asked about, which was 74. So we're on to normal distributions now. Cool. A normally distributed random variable x has a mean of 90. The probability that x is less than 85 is approximately 0.1587. Okay. So, sorry, Gyung has just asked in the text chat about how much IB exams count for your OSSD. So I've clarified that now. So let's get back to this normal distribution question. Important thing to note. So this question is in the non-calculator section. The miscellaneous questions in chapter 25, they're separated into a 25A and 25B. for non-calculator and calculator, and this one was a non-calculator, which I suspect is what would make it more challenging. Because if you had a calculator, this is straightforward. It's also why they have put the emphasis on estimate here, because you aren't going to find the standard deviation exactly, but you are going to get pretty close. All right. Sorry, answering things in the text chat again. I hate the time lag because then I know that when I'm typing, you're probably also hearing me talk, and then all of a sudden I go very quiet and I'm not typing, and it's weird. I need to find a better system or something that streams more in real time if such a thing exists. Thank you, Cam, for giving me your requests for some questions. I will go and grab those once I finish this one. Um, so, what it's asking you here, a normally distributed random variable, it has a mean of 90. So if I picture a rough sketch of a normal distribution curve, so there's the mean of 90 right in the middle, and they're saying that here's 85, and so from here down, this amount is roughly 16%. And so, thanks for the recommendation, Jake. So we know that in between these two is 68%. Oh, sorry. From one standard deviation below and one standard deviation above is 68%, which leaves over 32 that gets split to either side. So that means that there would be 16 this way and 16 this way. So the fact that they actually tell me that the probability that x is less than 85 is 0.1587, that actually tells me that 85 is one standard deviation below the mean. So then they say find the probability that x falls between 90 and 95. So that, in this case, would be, oh, that marker is way too big. That probability would be 34%. And then when it says to estimate the standard deviation, based on the numbers they've given me, I'm estimating that the standard deviation is 5. Because if 16% is below 85, that must mean that that's the value that's one standard deviation below the mean. So that's kind of it. This one, I don't like it too much as a problem. It doesn't strike me as being a really good example of an IB exam style question, because it is about recall related to those special values from the normal distribution. And I mean, it's good to know those to some extent, but most of the time the normal distribution stuff does show up on the calculator paper. So I don't worry too much about it. As long as you remember 68, 95, and 97 or whatever it is, then you're pretty good at knowing the different boundaries for the normal distribution curve. And 86B. Oh. Okay, so 86B got cut off when I screenshotted it, because my screenshot tool's being a real pain lately. This last part should be 0.6 to the 5, I believe. And this is meant to connect to this. So the whole idea here is what you're seeing is an expansion of the same form as the one above. So this is all equal to 0.4 plus 0.6 to the 5. So it's equal to 1 to the 5, so it's equal to 1, and that's it. That's all you would have to do for part B of that question. And part B was the only one that you did ask about, Jake, so I'm going to assume or hope that you're okay from there. And so now I'm going to go digging into Cam's questions. While I'm doing that, what other questions have popped up here? So Jake asked about or suggested I use Twitch to stream in the future, which I find particularly funny because Twitch is, I think, more commonly associated with being a game streaming platform, not just a general streaming service. Oh, whoops, I screenshotted Cam's, but he's actually updated his. So I'm going to pop those in. Well, Jake, I will have to check out Twitch, I guess, at some point. Seems like it might be worthwhile. Um, okay, so Cam is asking about number 36 from 25A. So I've got the textbook open already. I'll just nab a screenshot of that one. Oh, yes, this is an interesting question. I once put a question like this on a midterm exam, but I don't think it was with you guys. It must have been a few years back. Did I give you guys one that had a logarithm? I I've played around fairly creatively with the sequences and series type things. I've given ones that are um, that have logarithms built in, that have radicals built in, just all sorts of different twists on the established conventions. All right, so Cam said past papers, May 2017, paper 1, time zone 1. May 2017, paper 1, time zone 1, and we're looking at number 7 and number 10. Number 7. Oh, well, what are the odds of that? I was just talking about sequences and series questions that are based on logarithms, and that's exactly what this one is. And number 10 from this one I will also grab. Oh, yeah. Oh, this takes me back. See, it's funny. So this question, actually both of these questions that Cam asked about, they were on the IB exam that his brother would have wrote or written back when he was in grade 12. Because I remember very distinctly this question 10, a bunch of those DP2s came to talk to me after, and they said, oh my gosh, they had a probability distribution question that mixed in trig. And I said, oh, that's interesting. I wonder how they did that. And this is that question. And then it turns into a volume of revolution. So they were really pulling out all the stops on this question 10. Of course, now that I've built it up a little bit, it's not going to be the first one that I do. We're going to go back and do Cam's first request. So so two of these are basically the same question in principle. Maybe not in practice, but we'll take a look at them. So we're considering the infinite geometric sequence, and it goes 160, 80 root 2, 80, 40 root 2, and so on. And then they want us to write down the 12th term of the sequence in the form k root 2, which should be fine as long as we can figure out the common ratio, right? We're told it's geometric, so we know we're looking for a common ratio. So let's take u2 and divide it by u1 and see what we get. So 80 over root 2 divided by 160. So this ends up being root 2 over 2, right? 80 and 160, if you divide it out, you get a 1 on the top, 2 on the bottom, and then you're off to the races there. If you're not super confident that you did that properly, you can go ahead and divide the next two terms as well. They told us, though, that it's geometric, so I'm confident that we're going to get the same common ratio, which we do, even though it doesn't look like it. But we've talked a lot over the past 2 years about how root 2 over 2 and 1 over root 2 are the same thing. If I multiply on top and bottom of this fraction with root 2, I'm going to get root 2 over 2 here as well. All right, now that I know the common ratio, let's set up the general term. For geometric, it's u1 times r to the n minus 1. So my first term is 160. My common ratio is root 2 over 2. And if I am looking for the 12th term, then I will be putting on this the exponent 11. So as far as simplifying this, and it did say k is going to be a rational number. If you look back here, it says k is in the rationals. So I'm going to have to start evaluating this a little bit. Now this was a non-calculator 1-2. So I guess we'll kind of play around with how we simplify this without a calculator. We have 160, and it'll be over 2 to the 11. And on top, I'm going to change that that root 2 to be 2 to the 11 over 2. And I think we're going to actually try and simplify powers of 2 a bit here. 160 is the same as 16 times 10. 16 is 2 to the 4, and 10 is 2 times 5. So that means I can rewrite that as 2 to the 5 times 5. And then I'm multiplying that by 2 to the 11 over 2 and dividing that by 2 to the 11. So let's see what happens if I simplify my powers of 2. So 2 to the 5 times 2 to the 11 over 2, that's going to simplify to be the not super friendly 2 to the 21 over 2. And I don't like how I wrote that because it looks like a mixed number. I guess I'll write it like that. That's a bit better. And so then I have to subtract here a little bit. 2 to the 21 over 2 divided by 2 to the 11, I subtract the exponents. 11 written as a fraction over 2 is 22 over 2. So this ends up being 5 times, I'm doing 21 over 2 minus 22 over 2, so it's going to be 2 to the negative 1/2, which works out to be 5 over root 2. Now, they said it's not okay for me to write it that way. I have to write it in the form k times root 2. So this is another one of those situations where I need to multiply on top and bottom by root 2. And that is going to simplify to be 5 root 2 over, and then root 2 times root 2 on the bottom is just 2. And so if I wanted to write it as, k root 2, I think technically they would probably prefer you wrote it like this, although I don't think that they would penalize ever on an exam for not doing that. So I wouldn't be too fussed about that. Okay, on to number 7. And again, this is from May, now I forget, May 2017, time zone 1, paper 1. Which is making me realize that I haven't had a single request for a paper 2 question yet, but that's okay. I mean, I get it. Paper 1 is tomorrow, so you guys are prioritizing. That makes sense. Okay, so the first 3 terms of a Oh, why did I say paper 1's tomorrow? It's Saturday. What am I talking about? Paper 1 is on Monday is what I meant to say. Sorry for anyone who just had a minor cardiac event at the notion that their math exam was tomorrow and not on Monday. Anyway, for this question 7 from May 2017, time zone 1, paper 1, the first 3 terms of a geometric sequence are ln x to the 16, ln x to the 8, ln x to the 4, and it says find the common ratio. So with these right here, the tricky thing is undoubtedly that these terms have lns in them, and when you go to do u2 over u1, you end up doing ln x to the 8 over ln x to the 16. And then you might look at that and say, oh, what do you do from there? That seems ridiculous. But remember, we have a log law that says we can pull out the exponent from any argument in a logarithm and just pop it there in front of the logarithm. Right? It all comes down to the fact that when you go and actually evaluate that logarithm, any exponent would actually be left over anyway. That would be part of the result. And so we're able to use that here, pull out the 8 and the 16, and now I just have a ln x on top and bottom that can divide out. So the common ratio here is 8 over 16, or 1/2, which is a lot nicer than you might think based on the appearance of the question. I mean, it doesn't look like the common ratio would be anywhere near that tidy, but thankfully it is. And so the next part is especially interesting because the next part is asking you to solve something and there's sigma notation in it, and I'm confident that this is something that would put people off in the exam. This is a question 7, so it's not unprecedented for the question 7 to throw some curveballs in terms of difficulty. Because, like I said, the part A, it kind of progresses nicely. 1 to 5 should be fairly accessible to everyone. 6 is a little bit tougher. 7's where they start to really test you whether you know your stuff in a short question. And then when you go into 8, 9, and 10, they're longer, but it kind of gradually progresses up in difficulty again. So this being a question 7, I'm not at all surprised that they threw this into the mix. When I read this, though, it's the sigma notation, and it's saying the sum of terms of this type from 1 up to infinity. So that means it's actually an infinite sum that we're doing here. So we're figuring out, an infinite geometric sum of this sequence here. So the first term in that sequence would be 2 to the 4 ln x. Well, that's just 16 ln x. So even if you didn't realize it, it looks like the sequence that we are talking about is the one that we're given in the question. That's not necessarily immediately clear to people, but as soon as you find the first 2 terms, you start to realize, oh, okay, it's just that one. So I'm actually looking for just the sum of this infinite sequence here. So the sum of an infinite geometric sequence, the formula that you get for that tells you it's the first term divided by 1 minus the common ratio. So we've already figured out the common ratio is a half, and our first term is 16 ln x, right? So this is the sum that we're finding, 16 ln x over 1 minus 1/2 is still a half, so I just wrote it in a half instead of writing out the steps. When I divide by a half, I actually multiply by 2, so I get 32 ln x. That's the infinite sum. But they're telling me to solve the equation where this infinite sum is equal to 64. So the way I set up my equation then is that 32 ln x is equal to 64. So 32, 64, there's some commonality between those things. So if I divide 64 by 32, I just get 2. So ln x equals 2. If I rewrite that as an exponential, it becomes e to the 2 equals x. And I am done there. So it appears, well, actually, I shouldn't say it appears to be a challenging question. That was a challenging question. It's not one that's necessarily a cakewalk, but if you kind of keep a level head and say, okay, it has to do with logarithms, but it's also geometric sequences. So what do I know about log laws? What do I know about geometric sequences? And then put them together, then you will be able to get your way to the final solution. The sigma notation definitely throws a bit of a curveball into the mix. I can absolutely see why that would intimidate people. It's not uncommon at all. So as long as you just kind of keep your wits about you, you should be okay there. So Gyung's requested 9C from, I believe it was the same paper. So I just screenshotted that in. That is what you said, right? 9C from the May 2017 Times on 1 paper 1. Yep. Okay, so I popped that one in there. Maybe it would make more sense just from the perspective of doing this in the order it's actually showing up on the paper. I'm going to do Gyung's request for number 9 first, and then we'll move on to number 10 for Cam. As number 10 would be the hardest one on that paper. So, a quadratic function can be written in the form f of x equals a times x minus p times x minus 3. The graph of f has an axis of symmetry at x equals 2.5 and a y-intercept at 0, minus 6. So they say find the value of p. And I know Gyung didn't ask about a and b, but just for the sake of completeness, I'm going to run through them anyway. So they ask you to find the value of p. That's the other x-intercept. So we're told our axis of symmetry is at x equals 2.5. One of our x-intercepts is x equals 3. So whatever distance there is on the x-axis between my axis of symmetry at 2.5 and my first x-intercept at 3, it has to be the same distance to the other x-intercept in the other direction. That's the whole point of the axis of symmetry, right? The idea is the function's symmetrical around it. So if if the x point at 3, the x-intercept, is 0.5 above the axis of symmetry, the other x-intercept must be 0.5 the other way. So my other x-intercept is at 2, so that means that p is equal to 2. And so I'm done with that one there. So that ends up being 3 marks, I suspect just for the reasoning involved to get to that point. I'm sure in the mark scheme they had something where you could actually show a bit of an algebraic process, because another way you arguably could have done that by using more algebra is we know that the axis of symmetry is going to be some x value that's equal to the sum of my x-intercepts divided by 2. So you might have done 2.5 is equal to p plus 3 over 2. So 5 is equal to p plus 3, and then you get p is equal to 2 anyway. A few different ways to ultimately get there. So on part B, finding the value of a, this is where that y-intercept is going to come in handy, because now my function, as far as I'm concerned, is a times x minus 2 times x minus 3. So I know pretty much everything except that a value, and I've also been given this point, f at 0 is equal to negative 6. That's the y-intercept. So I can plug those values into the equation and solve for a. So I subbed in 0 for x, I subbed in negative 6 for y, and we're just going to simplify things a little bit here. So minus 6 is equal to a, and then this is negative 2 times negative 3, so that's 6 is the coefficient on a, and that means a must be negative 1. So now I have really the full function for f, which is helpful, I suspect, for part C. I vaguely remember this question. Not vividly, I'm sorry to say, but I'm pretty sure that the next part is a tangent line kind of thing in some capacity. So that's the function f of x. It's a quadratic, 2 x-intercepts. It opens down because of the negative in front. So part C says the line y equals kx minus 5 is tangent to the curve of f. Find the values of k. So at this point, there is kind of multiple ways that you could proceed with this question based on everything you have learned in standard level math. There is a way that involves the discriminant, for sure, because if I know that kx minus 5 is tangent to the curve, what that means is that they only intersect at one point. So if I take kx minus 5 and I set it equal to my quadratic, which maybe I'll expand that out, is going to be minus x squared minus 5x plus 6. So minus x squared plus 5x minus 6 once I multiply the negative through. So if I set those two things equal, I know that the resulting equation, when I move everything over to the other side, I know that it can only have one solution. So I move it all to one side, add 5 to both sides, so I have minus 1 there. This quadratic equation can only have one solution if they are tangent. That means that the discriminant has to equal 0. So when I find the discriminant here, I do b squared minus 4ac. The b value is 5 minus k, and a is negative 1, and c is negative 1. So this is going to expand out to be k squared minus 10k plus 25 minus 4. So k squared minus 10k plus 21 when I simplify that. Apparently I'm needing far more space for this question than I thought. And I'm not using the other half of my screen just because of the other strategy I want to show too. So the discriminant, as I have discovered it, is k squared minus 10k plus 21. And I've said that that has to be equal to 0. So I really just need to factor this quadratic. Two numbers that multiply to be 21 and add to be negative 10. Those numbers are minus 7 and minus 3. So that factors easily enough. So if k equals 3, then they only have 1 point of intersection. And if k equals 7, they only have 1 point of intersection. And so the other thing that I could do, actually, can I solve this with calculus? I think so. Because what I would be able to do if I use calculus, so we're told that y equals kx minus 5 is a tangent line. Well, the derivative of f, so f prime of x, it gives me my tangent lines. It gives me the slopes of them at least. So the derivative of that quadratic would be minus 2x plus 5. And so basically, I should be able to say, okay, the slope of this line is k. And so my derivative here, minus 2x plus 5, that has to equal k for certain values of x. Where can I go from there? Because at this point, I think I need a point on the line. Derivative is the slope of my tangent line. I've got my derivative. What else do I know to be able to plug in there? Oh, wait a minute. Okay. It just clicked in my head. So I'm okay, knowing that this is k is helpful, but I've kind of set it up wrong. I do still need to say to myself that these two things are crossing at some point. But then instead of using the discriminant, because I know that this is an expression for k, I'm actually just going to replace it in there. Minus 2x plus 5 times x minus 5 is equal to minus x squared plus 5x minus 6. That will work. So rather than using the discriminant now, I can just expand this out and see where it gets me. So minus 2x squared plus 5x minus 5 is equal to minus x squared plus 5x minus 6. Algebraically, I think this will work out to be a bit simpler. I'm moving everything to the right. Those middle terms are gone. That's convenient. And minus 1. And I get that that's equal to 0. And so that allows me to say that x is either equal to 1 or x is equal to minus 1, which is good because then I can pop those back up here into k. So k is equal to minus 2x plus 5. So it could either be equal to minus 2 times 1 plus 5. And if I do that one, it gives me 3. Alternatively, I could do minus 2 times negative 1 plus 5, which gives me 2 plus 5, which gives me 7, which was my other answer. So, well, writing them out, actually, the calculus one ended up taking up more space. I don't know if that's truly reflective of it being more complicated or not. I think I just didn't write that one out terribly efficiently. But there will be undoubtedly some questions where you can solve it multiple ways, as we just did there. And so, so you can take any strategy that you want. And I was just pausing there to chuckle at Jake's observation in the chat. Yeah, this question was able to be solved either way. So I guess we're kind of closing the loop there in terms of what we've done over the course of the last 2 years. We started grade 11 talking about quadratics and discriminants and come full circle talking about derivatives, and you can actually use both to solve those tangent line questions. And I mean, if you were a person who hated the discriminant, you could avoid it completely on this question. I don't want you to get into the habit of avoiding it entirely. I have definitely seen a question at some point over the past few years where it was a discriminant one, and I think the discriminant method of solving was much easier than the calculus method of solving. I'm pretty sure it involved a tangent somehow, and the derivatives were just a mess. So I wouldn't go down that road every single time, but you know, if you look at it and you see a way to solve it, then you just roll with it. All right, on to Cam's question. The question he said that gives his brother nightmares to this day. The question that had everything. Number 10 of May 2017, Time Zone 1, Paper 1. The following table shows the probability distribution of a discrete random variable A in terms of an angle theta. So it's a pretty simple distribution. The random variable can only take 2 numbers. A can be 1 and A can be 2. That's it. And then they ask you to show that cosine of theta is 3 over 4. That's the very first thing. And so I'm suspecting people would look at that and be like, what the heck? How do you even get from a probability distribution table with cosine in it in 2 different places? One of them's a double angle, the other one's not. How do you get from there to cos theta equals 3 over 4? And I'll admit, it's a bit of a stretch. So because this question just jammed so much stuff in together, I think that's one of the reasons why a lot of people were overwhelmed, or as Cam said, you know, given nightmares as a result of the way this question was structured. So you kind of have to take a moment and say to yourself, okay, it's a probability distribution question first. The trig stuff being in there is just extra. I mean, well, not extra. I don't think that's even the right way to refer to it. It's just adding a bit of extra flavor, I guess, to the question. But that's not the nuts and bolts of the question. Not really. So the actual first piece that you need to take into account here is that in a probability distribution, we know that all of the probabilities sum to be 1. And that's what's key here. So what that means is this plus this equals 1. That's one of the key things that we know about a probability distribution. So we have to imagine that that information, being really the only thing that we have to work off of at this point, that has to come in handy, right? So I set up the equation. It's basically all I can do. If you don't see that piece, then unfortunately the rest of the question is kind of inaccessible. It's why this wasn't one of my favorite questions I've ever seen in an IB exam. I thought it was interesting. I did think it created a false barrier to entry for no reason, but that's neither here nor there. So once you've set up this equation, now it's becoming more of a trig problem because I need to get cos theta by itself, which is essentially saying I need to solve this equation. That's the key. So I'm going to use some identities here. I'm going to have to because I have a cos 2 theta. Cos 2 theta is the trickier one of the double angles because there's a few different ways to write it. If I have to remember my goal is to factor this at the end and get cos theta equals something, then I've got to rewrite this into a form that just has cos thetas. So I don't want to do the cos squared theta minus sine squared theta. That's not going to work. I don't want to do the 1 minus 2 sine squared theta. That is definitely not going to work. But if I were to take that cos 2 theta and write it as shown, that's going to hopefully help me out. So I've got 2 times 2 cos squared theta minus 1. And all that's equal to 1. So if I multiply back out, I end up with 4 cos squared theta minus 2. And I'm going to just tidy that up and put everything on one side. 4 cos squared theta plus cos theta minus 3 equals 0. So now it's starting to look like a quadratic, which is great because I'm starting to take this question that seemed insurmountable right out of the gate, and I'm getting it into a form where I'm more familiar with it, more comfortable solving it. So if I were to do a little variable substitution here, so let's just, oh man, some of my markers are set to be absurdly large. Let's try that again. We'll let y equal cos theta. So this is now 4y squared plus y minus 3 equals 0. So I need to factor that. I need 2 numbers that multiply to be negative 12 and add to be 1. So those numbers would be 4 and minus 3. So that splits up nicely here, doing my decomposition method of factoring. Factor out the 4y there, I get y plus 1. Factor out the negative 3 here, I get y plus 1. So what I end up getting is that 4y minus 3 times y plus 1 is equal to 0. So this means y is equal to 3 over 4, or y is equal to minus 1. If I was to take that information and pop the cos theta back in, what I'm actually saying is that cos theta is equal to 3 over 4, or cos theta is equal to minus 1. And if I just left it there, I'm not sure if the IB would actually be overly punitive, because that's not actually correct the way I'm leaving it. Cos theta does equal 3 over 4. In this context, it cannot equal negative 1. And I'm sure that there were people who lost marks for that when this was written, because in a trig context, cos theta absolutely can equal minus 1. That's never been an issue. We said very early on when we were doing trig that the range of your sine functions is that sine theta was always between negative 1 and 1, inclusive, and we said cos theta was always between negative 1 and 1. We made those conclusions, and so a lot of people might look at this and say, yeah, I don't see a problem with that. They didn't ask me to show that. They only wanted me to show this part, and so I did, so I don't even have to worry about over here. But the reality is that answer is not okay, because if I go back through all the trig equations, this is supposed to be a probability distribution here. And the probability that A is equal to 1 is cos theta. So that probability equaling 3 over 4, that makes sense. That probability being negative 1, that makes no sense whatsoever. And so we have to actually reject the answer negative 1 because of that probability argument. The probability that A equals 1 cannot be equal to minus 1. Therefore, cos theta cannot equal negative 1. Now, I'm not sure off the top of my head how the IB would have marked that. And so I kind of want to pull open the mark scheme and scroll to, this was question 10. 10. Did I open the wrong exam? No. Okay, 10. Yeah. Yep. So according to the mark scheme, they would have taken off a mark for reasoning if you didn't reject the minus 1. If you just assumed that everything was good, then you would have actually lost out on that last mark. I'm gonna screenshot that into the mix here, just so you can see. So this was the note that would have been provided to all the IB examiners, the people who are marking stuff for that paper. So there's a reasoning mark at the end of the mark scheme that's awarded to that, and they say note, award, no reasoning marks if cos theta was not equal to negative 1 without a reason. So you did actually have to justify it. You couldn't just reject it because they said they didn't ask for it, which makes sense. They're looking to make sure that you're thinking about it. Okay, so that is 10A. 10B, given that tan theta is greater than 0, find tan theta. Okay. That seems straightforward enough, which I suspect is why it's only worth 3 marks. Yeah, the barrier to entry on this question was definitely part A. I think part B and C are actually much more approachable. 1 over cos x between 0 and pi over 2, volume of revolution. Yeah, I don't know that that one's actually overly difficult either. Okay, so tan theta is greater than 0. If I think about what that's communicating to me, I guess I know that we're in quadrants 1 or quadrants 3. But we've also already said that cosine theta is equal to 3 over 4 based on our work in the first part, which suggests we can't be in quadrant 3 because cosine would be negative there. So that is basically useful because in order to figure out tan theta, I need to be able to do sine theta over cos theta. Right? In order to get sine theta, I am going to have to use the Pythagorean identity, which says that sorry, I was trying to make a conscious effort to write my identities in a different color so that they would stand out. So the Pythagorean identity is sine squared theta plus cos squared theta equals 1. So I have to use all this information together to kind of sort this out. If I go to find sine theta, what I'm going to do is I'm going to pop 3 over 4 in for cos. 3 over 4 squared would be cos squared theta, and that's equal to 1. And if I just go about simplifying this, sine squared theta plus 9 over 16 equals 1. Sine squared theta equals 7 over 16. And so sine theta could be equal to plus or minus root 7 over 4. But again, we've already established that we're in quadrant 1. So sine theta is equal to just root 7 over 4 because sine theta must be positive. So now that I know this, I can pop that back into the equation for tan. So that was my first step. This is going to be my second step. Tan theta will be equal to sine theta, which is root 7 over 4, divided by cos theta, which is 3 over 4. So tan theta is root 7 over 3. And I think that's all it wanted, right? Find tan theta. Yep. Is that worth 3 marks? I mean, I guess so. Feels like there's a little bit more to it. But anyway, 3 marks is what they've allotted, so 3 marks I guess it is. So, part C is the volume of revolution thing. I'm just going to screenshot this again real quick so I don't have to keep scrolling up and down. Now, this was a paper 1, so the volume of revolution piece would not have relied on a calculator. So we're going to have to hope against hope here that when we go to do some integration here, that this is going to involve some special angles. All right. And I'm also fairly sure this is going to rely on some of the stuff that we talked about before, like earlier in the question. Even though this seems like it's 3 separate questions, I'm feeling like part C connects back to something earlier. Anyway, so y is 1 over cos x. And we're looking at it on the domain from 0 to pi over 2. We are taking the graph, though, between theta and pi over 4. And it's rotated 360 degrees around the x-axis. Okay. We're going to find the solid formed. That's interesting. Very interesting. Okay, so just based on the information that's there, and without thinking about it too much more, I've got to think of my volume of revolution equation, which it says in your formula booklet. I'm trying to think of how it's worded. Well, okay, I guess it doesn't matter. It's the integral pi times the integral from a to b of y squared. So a and b are your boundaries. So if your curve looked something like this, then a would be your lower bound, b is your upper bound, right? We have been given those by the question. This is a, this is b. Well, I mean, it doesn't say that technically theta is less than pi over 4. I'm just assuming that based on the way it's written. I guess we'll find out. So we'll leave pi there, untouched. We're going to put pi over 4 up here, and theta right here. And the function that I have is 1 over cos squared x, because it's my y, but squared. The tricky thing here, I suppose, would be maybe people aren't familiar with the integral of 1 over cos squared x, which is entirely possible. We did, as an exercise at one point, talk about the derivative of tan. And actually, okay, so this isn't on your formula booklet, I'm pretty sure. This tells you how often I look at the formula booklet. I probably should look at it more. But let me pull that up. Because they don't tell you the integral for cosine. No, they don't. Or, sorry, the integral for that leads to tan. They don't give you that antiderivative pairing. So you would kind of have to know this, which, I mean, hopefully is a fair assumption, but maybe it isn't. At one point, we did the derivative of tan x. And so tan can be written as sine over cos. If you were to take the derivative of that, dy by dx, you'd have to use quotient rule. So you'd have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator divided by the denominator squared. And so this works out to be cos squared x plus sine squared x on the top all over cos squared x. And so we did this at some point as an exercise in class. Cos squared x plus sine squared x is 1 by the Pythagorean identity. So I just have 1 over cos squared x. So once you've established that connection, that 1 over cos squared x is the derivative of tan, it should, in theory, make this um, doable to work backwards. I'm not going to say that it makes it easy, but knowing that is kind of a key step here. So the idea then is when I integrate, what I have is tan x as the antiderivative of 1 over cos squared x, and I am going to evaluate that between my upper bound pi over 4 and my lower bound, which was theta. Now, I suspect there would be many people here who start to kind of freak out at the notion that, oh, wait, I don't know theta. What am I supposed to do here? But that theta that we're talking about is the same theta that we were using up here. So we already figured out actually that tan theta is root 7 over 3. So in this definite integral that I'm doing here, tan of pi over 4 is just 1, so that's doable. Tan of theta, oh man, I just said it, but I forgot, is root 7 over 3. And so I swap those out, and now I'm kind of in business to solve this question without too much difficulty because well, I mean, I don't know how they want you to simplify it. I would probably leave my answer like this. Pi minus pi root 7 over 3. They might have gotten a common denominator and combined it. So it might be 3 pi minus pi root 7 over 3. I don't know. Either way, it doesn't look terribly nice. Let me close my formula booklet and open that back up. What did they put it as? Okay, yeah, so it looks like they mainly had accepted pi minus pi root 7 over 3, which was my first option. Yeah, so that question's a bit of a gauntlet. Probably one of the toughest question 10s that I've seen on a paper 1. Even last year's I don't think was that tough comparatively. So it's no surprise to me that it still causes Jacob to lose sleep at night. Um, this was a beast of a question. And if you look at what's assessed, it's assessing you on basically all your identity knowledge, your knowledge of solving trig equations, your knowledge of probability distributions to some extent. There's calculus in it, both derivative knowledge and integral knowledge. It was basically everything jam-packed together. And so, yeah, May 2017, paper 1, time zone 1, question 10. It was a lot. So hopefully, Cam, that makes sense. And to anyone else who's watching, hopefully that was helpful, especially if you've tried that question or looked at it and were just too terrified to even approach it. Again, I find the most important thing is if you can keep a level head about, okay, what is it that I know and what is the first thing that I can use, it'll help you get started on a question. And I think once you're kind of on the right path, it makes it so that you don't have to, how best to say this, you don't deviate so much that that you could make a mistake, I guess. I mean, so way back to part A, once I knew that the only knowledge I had that was helpful to me is that the sum of those probabilities has to be equal to 1, it got me started on that equation. And after that, pretty much all of my steps were just pretty clear cut. I knew I had to factor, so I had to use an identity. So then I factored it like a quadratic and got my answer. To figure out tan, right, I said to myself basically, well, what is tan? It's sine over cos. Great. I have cos. I don't have sine, so I need sine. That tells me my next step. And then I go back and figure out tan. And then this last one, again, I set up the integral and then just followed it through to its logical conclusion. I didn't get overly fussed by the fact that it was 1 over cos x, and that's a reciprocal trig function, which we don't talk about in SL. It's actually an HL topic, but not an SL topic. I didn't get overly fussed by that. I just kind of said, okay, well, it's going to be volumes of revolution, so here's what I do for a volume of revolution. Here's the integral it gives me. Okay, now what? And if you kind of just progress through things that way and don't allow yourself to get all spun about, then you usually wind up in good shape. Okay, so I've just put out kind of a general call for requests on questions. If anyone has either a topic or a specific question they want done, happy to do it. Um, in this lull, though, because I think Jake's left, I'm not sure who else is still here because the the watching, like the viewer statistics, keep fluctuating like crazy, and so sometimes it says that no one's watching, but then someone talks in the chat, and so I don't know what's going on. But anyway, I'm just going to respond to. I had a grade 8 email me about some math questions, so I'm just going to mute my mic for a second, quickly respond to them, and then I'll come back and tackle any other questions people might have. Um, I really did just want to make sure that people had an opportunity to ask questions before paper one. Tomorrow morning, oh God, not tomorrow morning. Why do I keep thinking it's Sunday? Um, sorry, Monday morning. I don't want my weekend to be over that quickly. I don't know why I keep trying to fast forward it. You guys have your exam paper in the afternoon. Um, and so in the morning we would have a DP2 class, and I don't believe that I have anything scheduled during that time. Our invigilation schedule keeps changing, but I don't think. Oh no, there's no. Hang on, there's no exams that morning at all. Is that true? Oh wow. Okay, that's actually perfect. Um, because then I have a period one prep and period three. I would have a gap in my schedule, so people can come in and ask questions in person too. There's a few opportunities for that. So that's on Monday morning, which is great. Then people can pop in before your paper one. Hmm. And then yeah, we'll do a debrief in the afternoon after the exam's done, kind of see how things went, and then we'll do a little bit of prep for paper two. Anyway, so I'm going to mute my mic, go answer that grade 8 question, and then I will come right back. I am still here monitoring the chat, I should add. Even though the mic's muted, I am looking to see if anyone requests something. So if you have a question, I will come back. questions rolling in yet? Nope. Well, then, I guess just operating on the assumption that anyone's going to look back and maybe watch this later. Do I have a timestamp for how long this has been? I think we've had a bit of a lull since. Oh no, that's the actual time, not a timestamp in the video. That's unfortunate. Um, okay, so it would have been for maybe the past 10 minutes. So from 140 to 150, kind of feels like we've had a little bit of a lull. Now I've got a cat who's trying to get some cuddles in while I'm trying to do work. All right, so I'm going to just kind of talk through a breakdown of the papers then and kind of make up a little grid here. So in SL Math, you've got a range of 6 topics. Algebra is the first one. Functions and equations is the second one. The third one, I believe, is technically called circular functions and trigonometry, but I'm just going to call it trig. The fourth one is vectors. And then we've got stats and probability. And finally, a little bit of calculus. And so those are the main topics that are going to show up on the exam. So if you are trying to prioritize your time in terms of preparing for these things, remember that you should do that based on how many hours are allocated in the syllabus. So the syllabus is on our HonestJK page. It's available through a bunch of other places too. But the DP Math syllabus has kind of the breakdown by time of how many hours of teaching were allocated to those topics. And so if you look at the breakdown of that, it should give you a sense of how many questions or how many marks are allocated to each of those topics. So it's 9 hours for algebra, 24 for functions and equations, which includes all your logarithms, exponentials, quadratic stuff, the discriminants in that topic. It's kind of a mixed bag of things. Trig and vectors are 16 hours apiece. Stats and probability is 35. Calculus is 40. And so if you were to kind of look at that in total and basically look at how many hours then that accounts for, you are looking at a measure of 140 hours. And so so if we were to kind of take that and divide up all of those, it gives you a sense of kind of what percentage of the exam is going to fall into each category. So, so algebra is not a lot. It's basically 6% of the course. Functions is 17% roughly. This would be about 11.5%, 11.5. I'm sure I'm going to end up with a slight rounding error by the end of this. This is about 29%. Does this add up properly? 29, 25, 11.5 and 11.5 is 23, 17 and 6. Oh, wow. Okay. That was perfectly 100. Okay, so that's kind of the breakdown. So we talked about this kind of back during the mock exam prep, where the way that you actually go about studying should be prioritized based on which topic's going to show up the most. And so you have 29% calculus, meaning that's kind of the biggest topic. 25% stats and probability. Functions and equations will be the next most frequently occurring. Vectors and trig will be kind of tied. And then algebra, so log laws and sequences and series and binomial expansions will be kind of the least prominent thing. Under algebra, you can basically assume that you'll see something arithmetic in some capacity, something geometric in some capacity, and a binomial expansion. And that'll kind of cover those topics. I think that's a fair assumption for any student going into the exam. Now, if you actually look, so for 180 marks, what is 6%? You would assume that 10 marks will be devoted to this category. Now, it's hard to make 3 questions, an arithmetic, geometric, and a binomial one, out of 10 marks. So sometimes this is actually more. It tends to be higher than what it should be based on the breakdown of time, just so they can assess you on all 3 skills. I have seen it before where it's a binomial expansion paired with like a derivatives question, which is entirely possible. And so to that end, I mean, they're kind of making it so that it's closer to 10 marks. I don't know. They get very creative with the way they come up with questions. Based on it being 17% of the exam, you would expect roughly 30 marks are connected to just the functions ideas. So log equations and graphs, exponential equations and graphs. You would expect transformations, inverses, compositions, that whole thing. And, oh, yeah, quadratics and maybe the discriminant. Those are the main topics. And if you're ready for those, then those 30 marks should be kind of a lock. The next 2 basically would have 20 marks allocated to them. I think trig sometimes skews a little bit higher just because of the volume of trig stuff, because there are equations, there are graphs that you would have to do of trig functions. There are all of the sine law, cosine law, the geometric applications. So that would be arc length and sector area as well. And that whole thing. All of that stuff will be in that 20 marks from the trig section, but it does tend to be a little bit more. The vectors is the one that does tend to be a little bit more clear-cut, because all the vectors skills kind of go together. You have to find the vector between 2 points. You have to find the magnitude of a vector. You have to find the angle between 2 vectors, all that kind of stuff. I'm sure if you've been doing past papers, you've seen it by now. The vectors questions do tend to be the bigger ones, and they do tend to kind of cover everything. Occasionally it'll be an applications question. That's entirely a possibility too. But the vectors questions are a little bit more clear-cut, and they do tend to stay closer to that 20 mark threshold. And then the calculus and stats and probability. So 180 times 25%. I don't even know why I just did that, because it's just a quarter. It has been a long day. But 45 marks would go to stats and probability, and that would mean my cat is headbutting my calculator now. I'm so glad we don't have cats on the school grounds. They would constantly pester me. So 52 marks will go towards calculus-related stuff, and that's actually maybe overly stating it. I have in the past done analysis of the exams, and it's pretty close, but I don't think it's that high. I'm pretty sure that the calculus stuff inevitably will skew a bit lower. There's a lot of calculus, don't get me wrong, but it's not usually that high. The stats and probability, though, seems right on the money. 45 marks, because that covers the questions you know will be on there. The linear regression questions, for sure, will show up. there will for sure be something about maybe a Venn diagram or probabilities, the probability of A and B, probability of A or B, that kind of stuff. There will be some sort of cumulative frequency graph. There will be measures of center and spread, that whole thing. Because they can give that to you in all sorts of different formats. And then there's going to be the probability distributions as well, binomial or normal distributions. Normal distribution questions, there's always going to be that paper 2 question in the level 8, 9, 10 range. And that's going to be, a big one. I think I can go into almost any exam paper and find that paper 2 question. And in fact, I might just now, because Cam said he was looking for paper 2 questions. I'm not sure if he found one that's been giving him grief. Let's go and look at the paper 2 for the year his brother wrote the IB exams. Paper 2. Paper 2. Scrolling down, we get to question 8, which was a trig functions. Question 9 was, a tricky one. Man, May 2017 time zone 1 was actually pretty rough. What did they have against Jacob's candidate class? I mean, really. So this question just looks really daunting. This is question number 9 from May 2017. And this is time zone 1, paper 2. So this would have been the exam paper that our students wrote. Random variable x is normally distributed with a mean of mu. In the following diagram, the shaded region between 9 and mu represents 30% of the distribution. So 30%. And there we go. I don't know if the mic actually picked up that noise, but that was some noise coming over the baby monitor. Apparently, Matilda just woke up from her nap. To be young and have the opportunities for rest in the middle of the day. What a concept. So, 30% of the distribution is in that shaded region, and we're asked to figure out the probability that x is less than 9. That's fairly straightforward. Less than the mean is 50% of your data. So if we have been told that 30% is there, that means it's 20%. That's less than 9. So the probability that x is less than 9, you could write it as 20% or 0.2 or 1 over 5, I guess, if you felt like that. And then that would be your answer for that one. They say the standard deviation is 2.1. And then they say find the value of mu. So that is maybe a little bit trickier, possibly. You do have a calculator on this question, which is important to note. And so if you look at what it is that we know so far, you know that mu is equal to you don't know that mu is equal to anything. That's what we're looking for. You know that the standard deviation is 2.1. And we know that the probability that x is less than 9 is 0.2. And so, if I was to go onto my calculator and use a distribution here, if I use the inverse normal distribution and pop in 0.2, and just leave the mean as 0 and the standard deviation as 1, that's going to give me a z-score. So I used inverse norm because I basically was looking for the z-score that makes this true. And so the z-score that I get is negative 0.8416212335. Yeah, I didn't round it. I maybe could have, but it's okay. And so I know that the z-score is equal to x minus mu over sigma. So if I want to get mu, I basically will have to rearrange this a little bit. I'll do z times sigma, um, and I'll subtract that from x, and that's how I'll end up getting mu. So I just rearrange that equation real quick. And if I just plug in the things that I know, I'm all set. So x is 9. My z-score is minus 0.84. I'm not going to write it out again. I have it in my calculator, so it's fine. Times 2.1, that's all equal to mu. So if I punch that into my calculator, because again, this would be on the calculator paper, I get that mu is equal to 10 point, I guess I'll round it to 10.8 if I'm doing 3 significant figures properly. And so that would be my answer for part B. And I guess it's once we get into part C that maybe it gets a bit wonky, because the random variable y is normally distributed with a mean of, this is a lambda, and standard deviation 3.5. The events x greater than 9 and y greater than 9 are independent, and the probability that x is greater than 9 and y is greater than 9 is equal to 0.4. So this is the information that they're giving us, and they're telling us to find the mean. So what this, okay, that block of text basically gives us a ton of information, even though it only was, what, 2 sentences? Yeah. So we know that y is distributed normally, its mean is lambda, and its standard deviation is 3.5. That's helpful, but not entirely sufficient to solve the question on its own. But we're told that x being greater than 9 and y being greater than 9 are independent conditions. So x doesn't influence y and vice versa. And we're told that the probability that x is greater than 9 and y is greater than 9 is equal to 0.4. Now, if I just write down the numbers that I've been given, I am missing one fundamental piece, which is that these events are independent from each other. When probabilities are independent, the probability of A and B happening together is just the probability of A times the probability of B. So this is true if they are independent. And so to that end, I can just go and evaluate here. The probability that x is greater than 9, I kind of know, don't I? Because earlier I know the probability that x is less than 9 is 0.2. So the probability that x is greater than 9 is 0.8. The probability that y is greater than 9, I don't know yet. But I'll be able to figure it out, because basically what we've determined here is that 0.4, the probability that both of those things are true, is going to be the probability that x is greater than 9, so 0.8, times the probability that y is greater than 9. And so if I isolate that probability, I will be getting 1/2 here. The probability that y is greater than 9 is equal to 1 over 2, which hopefully we can see what the utility is of that. The probability then that y is less than 9 is also 1/2, which tells us something very important about 9, doesn't it? If half the data is above and half is below, that means that 9 is actually the mean. So I would say, therefore, the mean, lambda, here is 9. And then we're all set. So I think what makes that question seem particularly tricky is that they're combining the notations that we've developed for probability distributions, where we have a random variable and then we're setting conditions on the random variable, and that whole piece. They're combining that way of thinking with the probability that we used when we were just saying, okay, probability of A, probability of B, and we were talking about events instead of random variables that took a certain value. And so it makes it a little bit more confusing, I think, because people, again, this is one of those situations where I can just picture a fair number of IB candidates looking at this and being far too intimidated by it to continue to work through it. And so, yeah, I mean, again, I can see why that's a question where people would perhaps be a little intimidated because they were nervous about the complexity of the question. And so they say, given that y is greater than 9, find the probability that y is less than 13. So this is actually, even though it wasn't written that way, which I actually, now looking at this in hindsight, I kind of have a problem with the way that that's written. But I mean, the IB gives you the opportunity to fill out a form if you think part of the exam wasn't fair. I didn't look at this one, I guess, that closely. I did the question, but I didn't at the time think it was worded in a weird way. But now that I'm reading it, I'm kind of thinking, oh man, how many people just figured out the probability that y is less than 13 when I think it's actually asking the probability that y is less than 13 given that y is greater than 9, which is different. But, I mean, is that unfair or is it just testing that you're paying attention? I don't know. All right, so this would be the probability that y is less than 13 and y is greater than 9 divided by the probability that y is greater than 9. So I'm just using my formula for dependent probabilities here with this notation that we use for random variables. Now, I can rewrite this in a better way because the probability that our random variable is less than 13 and greater than 9 is actually just the probability, and I'll rewrite it like this, that y is between 9 and 13. So we've already figured out the denominator here. The probability that y is greater than 9 is 1/2. The probability that y is between 9 and 13, I can figure out because I have my calculator and we have now determined the mean. So I'm going to go into my distributions window, access normal CDF. My lower bound I'll put in as 9. My upper bound I will put in as 13. 9 is the mean, and the standard deviation I think was 3.5. And so basically I'm going from the mean, which is at 9, up to 13, which is just a little bit past one standard deviation above the mean. So I would be expecting this to be a little bit bigger than 34% roughly. So let's see what we get. And I get 0.37345099936. So if I take that answer and, oh, I almost multiplied it by something, but I want to, oh wait, no, I am multiplying it by 2, aren't I? Because I'm dividing by half. Let's try that again. I pressed the wrong things. So if I double that, I get 0.747 if I'm going to 3 significant figures. And so that's an example of one that has to do with a normal distribution. It's interesting because I think May 2017, time zone 1 was a bit of an oddity in terms of the normal distribution question. If I look at time zone 2 for the same, yeah. So time zone 2, paper 2 for the same year, their question 10, it gave a probability distribution in a table. They told you what the expected value was and some of the probabilities were missing. And so you had to go and solve for the missing ones. But then it switches to like a standard, it's binomial at one point and then it's normal at another point. And that tends to be how those questions are more likely to be structured. I'm just looking back at 2018. What was 2018's probability question? Did I open the right paper? Yeah, and so 2018 was one where it was a bit more clear cut. And so we've got this one. Why are they pasting in so small? Is my page, what's my page width here? Yeah, they shouldn't be pasting in that small. Oh well. This one's from May 2018. Paper 2, time zone 1. May 2018. Paper 2, time zone 1. And this is more what the normal distribution questions look like. The weight in grams of oranges grown in an orchard are normally distributed with a mean of 297 grams. It's known that 79% of the oranges weigh more than this, 9.5 weigh more than that. Yeah, I've seen this question a million times, once with trees, once with fish, once with yogurt. Um, it, these are the far more commonly occurring normal distribution questions. Uh, Now, I guess maybe what I'm curious to know. Okay, so May 2017 didn't have one of those. Let's look at November 2017. November 2017 had it. Okay, so it also had an irregular one because it gave a table. So that's interesting. 2017 was the year of the irregular probability distribution question as far as the IB's normal stuff is concerned. Um, 2016. Let's see. That's trig. That's calculus. Oh, and they had a cumulative frequency graph. It wasn't even probability on paper 2 for November of 2016. May 2016, time zone 1, which would have been us, had distribution graphs again. Or tables, I mean. Sorry, not graphs. And time zone 2 had linear regression. Oh, boy. Oh, well, okay. Their question 9 and 10 were a bit tougher. So I guess the question 8 was a linear regression, and time zone 2 is a bit of a freebie, if you can ever call it that. So, I mean, normal distributions, at the end of the day, probability distributions or some complicated stats question is going to show up on paper 2 in section B. Most of the time, it's a probability distribution, a simple normal distribution curve like this, a little bit more abstract like this one, but it'll be there nonetheless. Well, the size of my writing has really varied over the course of this. I'm going to reorganize this. Just for anyone who doesn't end up watching the video, but perhaps comes and pops in later to the OneNote to see what's going on. Should be trying to keep this in good order. All right. When did I say this would end in the announcements? I think I said I'd be available from 1 to 4, but it seems like there's not too many people here. There's at least one person based on the viewership. And I don't know if there are any requests at this time. Okay, so I'll stay on the stream for another 9 minutes or so. If there are any other requests, I'll answer them in that time. And then otherwise, I'll log off. I suspect most people are probably busy, or I mean, even just outside. I don't know what it's like where everyone else lives, but in Waterloo, it's a beautiful day. So I wouldn't begrudge people doing some studying outdoors or away from a computer screen. Makes complete sense to me. I will also say this for anyone who checks out this stream at some point after it's done, because I'm pretty sure it gets saved to YouTube and then you can play through it again. There, okay, so there's a bit of time in the middle where I was waiting on requests and I didn't get too much stuff coming through. Sounds like Tilly's awake and throwing toys upstairs. Um, anyway, what was I going to say? So the video, I don't think I can edit it once it uploads to YouTube, so there will be a bit of a lull at some point in the middle. I'll make a note for people to kind of skip past that. I'll change the description of the video or something to make that clear. And what else? If you have any other requests or questions or things like that, just send me an email. I've got my Surface. I can absolutely answer any questions. Send me a picture of your work or a screenshot if you're doing it on your computer, and I'll get back to you. Um, I mean, aside from it being Mother's Day weekend and Mother's Day related plans on Sunday, I should be able to answer questions. I may just not get to them immediately. Um, and I only have just a little bit of marking at this point because you guys are gearing up for exams and my grade 8s are gearing up for exams, and so it's just my grade 11s who wrote a stats test recently that I have to get through. So other than that, I should be okay to answer any questions as they come in. I'm just sorting videos for design Well, I wait to see if there are any other requests in the last bit, but I don't think there's going to be. Maybe I should just wrap this up now. I said 3:25, hoping against hope that someone was going to pop in, but I don't think there is. So I guess I'm going to stop the stream there. Cam, I think you're the one who's still on, based on the fact that there's another viewer. And so hopefully, if you have any questions, just make sure to um, send me an email, and I will get back to you. Good luck with your studying, everybody, and hope the exam goes well on Monday. If I don't see you on Monday morning, hopefully everyone will come and see me after. All right, so I'll end the stream here, and yeah, good luck on the IB exams.